Hello, in this video I'm going to be covering my assignment 3 for medical robotics and systems class, and there are going to be 3 parts to this assignment. I'm going to start with the first one where I've created a function in MATLAB that allows me to outline a region in the slices of MRI scan, and after I outline those regions I'm able to create a 3D model of that structure. So I'm gonna go ahead and show you. So this program is gonna bring up a number of slices one at a time, and it's waiting for me to outline a region, and I've choose this eye section here, and then the other slide is gonna pop up, and I'm outlining the region I want. I believe this is probably the last slide. Okay, so I have segmented out those regions, and after that the system will create a 3D model of that segmented region, and here it is. And I went through from slice number 2 to slice number 6, and there is going to be, we've assumed that there is 1 centimeter of thickness between each slices. So that's what it looks like. Alright, so that was the first part of the assignment, and I'm gonna go to the second one, which involves using a 3D slicer to do similar thing that what we did in MATLAB, but we're gonna use a 3D slicer software to load an image and again segment out a region that you want and create a 3D model of that. So I have these slices from different view, and that's the 3D model that I segmented out, which is the tumor. Here you can see that I have highlighted or painted the region that I want, which is the tumor. You can see it here, and that's the 3D model. And I can quickly show you how I created this. Or I loaded the sample data, which was the brain tumor 2. Here, oh my god, I should have closed the scene. Okay, here it is, the unhighlighted image. Let's look at the red only slice. And I believe I'm gonna go ahead and find the region where I can see the tumor better. And here it is. And then I went to editor. There's a paint effect here. Just gonna make the radius smaller so I can highlight it better. And for the first one, I need to be very careful of the region I want highlight. It's a manual segmenting process, so okay, and then after that we can go ahead and press the threshold effect. That will make it semi-automated, and I'm just gonna find the range that highlights that region that I want, and I can see it for each slices to make sure that it's highlighted, so I can best pick my threshold range. In fact, I can just check in here, and that looks like that's my range where I can go. Yeah, this should do it. So then now I can use this threshold range for paint. So I'm gonna say use for paint. Okay, now I can continue to highlight. This time I don't need to be very careful when I highlight because I already have the threshold range, so it's only gonna paint the region that I want, the tumor region. So I can quickly highlight, oops, and there it goes, just that region, right? So the threshold makes it semi-automated, which helps. Okay, so that's it, and I won't go through each slice that how I did it. I already created it, you know. So, and make model effects. When I do that, and I'm gonna go ahead and apply to create the 3D model. And here it is. It's not massive as the one I showed before because I went through each slice for that. The slice that has the tumor visible. But here I only did a few of the slices. So if we continue applying the same method, then we can get the 3D model that we got previously. So that was the second part, and I'm going to go back to MATLAB to cover part 3. The third part of assignment 3 is a registration of points of the same object in two different coordinate systems. And for this part, I've written an objective function which is going to take in an input value of a vector xyz yaw pitch roll, and it's going to return an error between an actual and a computed position values. And let me go ahead and so that's the initial Gus value, which is actually the initial value for the objective function that's written. And we're going to run this fmin search algorithm, which will be using an objective function. And the initial guess value, it's going to start from the initial value of the guess value of this, and it's going to run calling this objective function until the error that's computed that's returned from the objective function is close to 0. Then once that error is 0, this fmin search is gonna return a value for this xyz y pitch roll that is the correct value or the original value of this transformation matrix. So if I run this fmin search and find t is a function that I wrote, it's an objective function, and this xyz y pitch roll is initial or gust value that we initiated, and after it runs, when the error that is going to be returned from this objective function is close to 0, then fmin search will return original value or the correct value of the xyz yaw pitch roll. So I'm going to go ahead and run this. You can see that the error is going down, and yeah, we got it close to 0. So when that error is 0, then it's going to return the original value of this xyz and yaw pitch roll. And we have 0, that is 1, 0, 0, pi, and negative pi. Okay, that concludes my the 3 parts of my assignment 3, and thanks for watching.